Welcome to compound inequalities. Okay, so you guys, we've solved inequalities so far, but now we're going to look at compound inequalities. And you think hopefully compound, you're thinking more than one. So these are statements that are going to contain either an and or an or, and it's going to contain multiple inequalities. And so what that might mean is multiple constraints on our variable. So let's go ahead and look at an example here where we're going to solve inequalities. So an and statement is really going to look like this. So you're going to have, let's say, negative 5 is less than or equal to x minus 4, and that's going to be less than or equal to 13. Now there's two constraints going on here. There's two inequalities, and number one of the inequalities is here. X minus 4 has to be greater than or equal to negative 5. That's one of our constraints. So we're going to go ahead and write that over here. We're going to solve this inequality. Negative 5 is less than or equal to x minus 4. And here's the big thing, and there's another one in here. We have to solve this inequality. X minus 4 has to be less than or equal to 13. So that's the other inequality I'm going to go ahead and solve. So x minus 4 is less than or equal to 13. Okay, so there's other ways you can solve this, but I broke it apart, which can be the easier of the two. So we're going to start on the left by adding 4 to both sides. So we're going to go ahead and add 4 to both sides, and that's going to give us negative 1. And that's going to be less than or equal to x. So in the grand scheme of things, x is greater than or equal to negative 1. So don't forget to write our and let's not forget about this inequality. We're going to add 4 to both sides here. And interesting, what you do on the right side of the inequality and here, when you rewrite this, you're going to do the same steps. Okay, notice how we add 4 here and we added 4 here. So now we're going to have x is less than or equal to 17. Now, if we want to draw this on a number line, we can look at the solutions. Okay, and obviously this is not going to be to scale. So we have negative 1, and way down here we have 17. Now these are closed circles because of the inequality of the lines underneath. So x is greater than or equal to negative 1 goes this way. Okay, and x is less than or equal to 17 goes this way. So we're looking at the overlap would be the solutions to both inequalities. So the solution set on the graph is right in here. That's where the overlap of the two lines are. Okay, that's the x values that make both of those inequalities true, because you need both and. Okay, so that's one of our examples. All right, so let's move on. Let's look at another example of this, and we can look at negative 12 is less than 2 minus 5x, and that's less than or equal to 7. Now there's two inequalities here. So there's a left side here of there's a left of the inequality, right, and there's the middle, and then there's the right side. So I could actually do the same thing all 3 times to each spot, but meaning I could subtract the 2x from both sides if I wanted to, okay, and to all 3 sides. But it's a little bit easier if we rewrite this inequality, so that way you don't make really any mistakes. So we're going to go ahead and rewrite this to 2 equivalent inequalities here. So we're going to have, remember, negative 12 is less than 2 minus 5x, and there's that and again because we have 2 constraints, and 2 minus 5x is less than or equal to 7. So let's go ahead and solve each of these inequalities now. I'm going to go ahead and look, and I'm going to subtract 2 here. And you could do these at the same time. If I subtract 2 here, that means I'm going to have to subtract 2 over here. Okay? And now I have negative 12 minus 2 is negative 14. And that's less than negative 5x. Okay, and I'll just stick with the left side here. Now I have to divide by negative 5, and that's going to change some things, isn't it? We're going to have 14/5 is greater than x. So x has to be less than 14/5, okay, or 2 4/5. So we can rewrite that 2 4/5 is greater than x. On the left side here, or on the right side, these become 0. 7 minus 2 is 5, so we have 5x is less than or equal to 5. So divide everything by negative 5. And we have now x is going to be greater than or equal to negative 1. Okay, so if we add a little bit more to our board here, we can rewrite these. So our interval notation is going to be including negative 1, so negative 1 to 2 4/5. And that's going to be open circle here because there's no line underneath, so that means it's parentheses. So that's our answer in interval notation. In between negative 1 and 2 4/5 are where all the x's are going to lie, where the solutions are going to lie to both those inequalities. So if we did it on a number line, you would have negative 1, you have 2 over here, 3, okay, and right here, a little before that, is going to be our closed circle to our open circle. Okay, 2 4/5, and at x is greater than or equal to negative 1, there's a closed circle there and up and over, and you can see the overlap there is where we want the solutions to be between those two, and that's what our interval notation here represents. Now with the OR statement, you're going to have it split up. You're going to have, let's solve for x minus 1 is greater than or equal to 7, or 9x over 2, so 9/2 x, is less than 3. Now the OR statement means you can have an x that makes this inequality true or this inequality true or both. So you don't need to satisfy both these constraints. Only one of them has to be satisfied, and that's different than the AND statement. The AND statement is both constraints. So I can go ahead and solve these now. I'm going to solve by adding 1 to both sides. Okay, and so I'm left with 4x is greater than or equal to 8. And that means x is greater than or equal to 2. Or now I'm going to go ahead and actually multiply everything by 2, okay, to get rid of that fraction, and that's fine. There's other ways you can do this. So I get 9x is less than 6. Okay, so I divide each side by 9, divide this side by 9, and I get x is less than 2/3. Okay, so those are my solutions. So if you did this on a number line, okay, we would go out to, let's say, 0, 1, 2. X is greater than or equal to 2 is going to go this way. Greater than or equal to, fill in the dot, goes to the right. And 2/3 is a little bit less than 1, open circle. And we're going to make a big open circle there and this way. So those are all the x's that satisfy our solution. If we wanted to make this into a interval notation, we would have from 2 to infinity, or 2/3, well, we can do it this way, negative infinity to 2/3, open circles, okay? So that's going to wrap it up for compound inequalities with the AND OR statements. So just be careful on which one you're using. Remember, AND, you have to satisfy both conditions, or you only have to satisfy one of those conditions. And when we mean by conditions, we mean constraints. So any questions or comments, you can type them below or email me, and we'll see you next time.